Ma'am, we are very thankful to you for joining. I would request one of the participants to kindly introduce ma'am, Jigyasa.
Yes, sir.
Kindly introduce ma'am, and then ma'am, the session will be all for you.
Good afternoon, everyone. Today we have with us Dr. Pradeepika Verma, Faculty Fellow, Technology Innovation Hub, Indian Institute of Technology, Patna. She received her PhD degree in Computer Science and Engineering from Indian Institute of Technology, ISM Dhanbad, India in 2020. She has received her MTech in Computer Science and Engineering from Vanasthali University, Rajasthan, India in 2013. She has worked as postdoctoral fellow funded by SERB in the Department of CSC, IIT BHU. Prior to this, she was worked as an assistant professor in Department of Computer Science and Engineering at Pranivar Singh Institute of Technology, Kanpur, India, and as a faculty member in Department of Computer Application at Institute of Engineering and Technology, Lucknow. Her current research interests include natural language processing, optimization approach, and information retrieval. She has published many national and international papers and conferences. Today, she is with us and she is going to deliver her expertise in deep learning in natural language processing. We welcome you, ma'am.
Okay, thank you so much, Jigyasa, and thank you so much, Professor Mayank Agrawal. So today I am here uh, with a discussion on the topic of deep learning in natural language processing. So I am Pradeepika Verma, and my introduction has already given by Jigyasa. So I'm starting with this topic, the discussion on this. I'm sharing my screen at first. Is it visible to all of you?
Yeah, visible
Yes,
ma'am.
ma'am.
Okay. Yes. So, the topic of discussion is deep learning for NLP, that is natural language processing. So, as we know that in the current era, natural language processing domain is booming due to just because of the introduction of the deep learning approaches, right? So in the NLP we have seen that the working on NLP has been done previously from many years ago, and at that particular time uh, NLP has been processed using some heuristic approaches or some probabilistic based approaches. So, at that particular time, whenever we are talking about any application of NLP, we have achieved some the performance for that particular NLP in some moderate way, or we can say that the performance of that particular application is not very well. So at that time, NLP applications are not using so much in a very fluent way, we can say. So why deep learning approaches has been came into picture in the domain of NLP, and why, since this deep learning approaches are also very has been proposed since 1980, that has been came into picture, right? So, why at that particular time deep learning approaches has not been adopted in the field of NLP, and now since 2014 or 2017, when transformer models or encoder decoder architectures has been came into picture, the NLP applications are booming. So, if we talk about the status of natural language applications, so if you will notice that wherever you are sitting, from that you can be able to access the information or news for any place, right? For suppose that you would like to find the latest news which is going on the Kenya, right? So if you will go to access that, and whatever information you are accessing, that information can be written in that particular language. So what happens that it is not easy for every one that to know the particular language that in which language the information has been written. So as you can see here that whatever the information has been retrieved from the system, if you will do the translation of that, which is on that particular language, which is relevant to you, right? Like if you know English, right? In that particular English language, if you know that what is the information can be written here, you will easily capture the information. So in that case you can easily do the translation. And uh, what is the status of neural machine translation in today's era is that you can capture from this example that how it is giving the translation of that particular information, and that is very accurate. Another example you can take, that is if suppose that you would like to know a particular information for which you know some hints or prompts. So by giving prompts into the form of human languages, you can also give you can also extract the information, or you can capture the information. So if you will go through with the chat GPT, there you can give the prompts for the particular domain, and from that you can take out the answer. You will go through with that particular answer, and in a very the performance of these whatever the systems we are having, that can be uh, very good, we can say. Another thing you can see that how the performance of ChatGPT we are having. We can draft any kind of application. We can give the questions to the system that is ChatGPT, and from that we can find out any kind of answer like this. If you will see the answer of applications, right? And also you can go through with this particular image, and for suppose that this particular image you would like to ask that what is the unusual in this particular image, you can get the answers from in a accurate way from the chat gpt or gpt model. So, we can say in today's era, in our daily life, these natural language applications are working more, and we are dependent on these kind of applications, right? So, let's talk about at first the what are the natural language processing basics are there, and from then we will coming towards the deep learning approaches, so that we can know that how the evaluation on the NLP, natural language processing, has been came since from the heuristic approaches towards the deep learning approaches, and how these NLP applications are booming. So NLP is natural language processing is the technique that is used by machines to understand, analyze, and manipulate and interpret human languages. So the goal is to interpret the language, whatever the uh, information has been given, into the form of human language, and from that, after interpreting, you can be able to generate the system can be able to generate the answers from that. So this is the only goal for natural language processing we have. Now if we talk about the levels of NLP, that in which levels the processing can be done. So if you think about this, that is in which form we can give the input to the system, and once we have given this input to the system, how these informations can be processed. So the system, we can give the input to the system into the form of speeches, as well as into the form of natural language text. So if we talk about the speech, right? So in that case, you would have to go through with the phonological analysis. And if we are giving the input to the system, so in that case, you would have to recognize, you have to do some another kind of pre-processing, like you would have to identify that in which language you have given the information, right? What are the unique or unit terms are there, uh, to combine that particular terms, information or a sentence can be formed here. So these are some kind of things you can go through. So here we have the speech analysis, and we have to go through with the phonological or phonetic analysis. Then you can have to go through with the tokenization. Then you would have to go with the morphological analysis, syntactic analysis, semantic analysis, and also some another kind of analysis like discourse or pragmatic analysis. So what is the need of this, right? So for suppose that you have given your information into the form of speech, so in that case it may create some kind of ambiguity for the system to capture the input, right? For suppose that I have given you the example of uh, uh, I got a plate, right? So suppose that this sentence I am giving you, giving to a particular system. This sentence, if you are not properly utilizing the boundary to specify a particular word, the system can be confused, right? Either it can have the meaning that I got up late, or it can have the meaning that I got a plate, right? मुझे एक plate मिली, right? So that is the ambiguity. This is the a kind of ambiguity to which system should be processed in terms of taking out the correct input. Then for the in the case of morphology, right? Morphology is the case in which you would like to process your data, which is written in the form of text, into its root, whatever the root of this particular individual unit is there. Since you have done the tokenization after giving taking out the input from your data or from through the speech or text, what is the essential thing you would have to do in terms of processing your data? That is, at first you have to do the tokenization in terms of recognizing each and every individual statement or individual terms. So that can be done in various stages, like it can be at sentence level, it can be a word level, or it can also be a sub word level, right? In which uh, a particular word you are tokenizing into two parts, right? So that is called the process of tokenization in terms of recognizing the individual terms you are having. Then you are having the morphological analysis in which you are doing the stemming in the sense you would like to find out the origin of generation of a particular unit. So for suppose that you are working on a search engine. So in a search engine, whatever the query you are giving to that particular search engine, how it process, it does not take into account that whatever the whole sentence you have given, it takes out the keywords, and from by taking out that particular keywords, it is it search the particular document which is relevant to that particular keywords. So in that case, what would happen that sometimes it is not necessary to have a word to be appear in a more complex way while we are searching the documents. So we can just simplify that particular units into the form of their morphemes, so that we can just simplify that particular process of searching. So for that requirement, we can do morphological analysis, then syntactic analysis about how we are analyzing the structure of a given unit, right? A structure can tell you that whether that particular information information, whatever you have given in the form of human languages, whether it is correct or not correct, right? So for suppose that you have given uh, mm, some sentences into the English language. In that case, you know that a particular English sentence can be formed in the structure of SOV, right? Sorry, SVO, right? So if this is the structure, how this structure should be analyzed, and in terms of came to know that whether the given sentence is syntactically correct or not. So for this thing we have to do the syntactic analysis, then semantic analysis. Of course we can have that uh, uh, in terms of processing the textual units. Only the syntactic information which we have received after the syntactic analysis, it is not adequate, right? Or it is not sufficient. So and just because that, for suppose that we have taken an example of visiting aunts can be nuisance, right? So in this case it can have two meaning. Either I am going to visit to the aunt's home, or it can be that aunts would be visited to our home or my home. So in this case, what would happen that if we are not defining that whoever is whoever is playing the role of agent and whoever is playing the role of uh, beneficiary, in that case we cannot exactly define that what is the correct meaning of that particular sentence. So in that case, we would like to process the data into the form of semantic analysis. Then discourse analysis will tell you that for a particular given discourse, right? So for suppose that we are having a conversation with each other for a particular topic. Whatever the conversation at a particular time we have done, that can be taken as a discourse, right? So according to that, in the context of that conversation, the meaning of a particular word can be changed, right? So for that, we have to analyze that whatever the proper meaning of there. So these are several levels into which we can process the textual data, right? So this is the basic approach in which we can have to do that. We are making some rules on the basis of these analysis, and we are taking right decision. So these were done in the earlier era, whenever we have not adopted the deep learning approaches into the field of NLP. So this is about the basic approaches. Now if we talk about the NLP applications, NLP applications can range from simple to complex. It can be a application of spelling checking, keyword search, finding synonyms. It can be extracting information from the website such as product price, dates, locations, people, or company names. It can be a classification problem or classification application, reading levels of school text, etc. In the more complex application, we can have machine translation application or spoken dialogue system or complex question answering system. So these are some of the applications in which NLP can have a wide role or a major role. It has existed, right? So why NLP is hard, as we have discussed in the NLP levels. So in that, we have discussed that whatever the language we are using in terms of communicating with each other, or and how we are generating the information, it can be easily understandable for a human, because we know that in which context a particular text has been appeared. But for a system, it may be very complex or very ambiguous to capture the right meaning in that particular context. For suppose that you analyze this particular example, that is I saw the boy with a telescope. So if we know that in which context whoever is talking or whoever to whom we are doing the conversation. So in this case, what is happening, that we know the context and we may easily capture that whether this telescope, this uh, part of the sentence is associated with I or the boy, right? But if you are not giving any contextual information with this particular sentence, it would be very hard for a system to capture the meaning, a correct meaning of this particular sentence. So this is creating the ambiguity. So there are various kind of uh, uh, various kind of informations are there, or uh, text are there in which you can find this kind of ambiguity. This is a very simple ambiguity which has been occurred, to which we have illustrated, but there can be many more things which can be appeared as ambiguity in the natural language. So here we would like to talk about how deep learning approaches came into picture into the field of NLP, since the NLP domain is very hard to adopt the deep learning approaches in earlier era, right? So why it is hard? So we know that in the deep learning approaches we are having some since whatever the form of data we are having, that is in the form of natural languages to which a particular system cannot understand. So in that particular case, what we have to do, we have to transform our data, textual data, into that kind of form formats in which deep learning approaches can be applicable. So we can have various approaches in the earlier era, like we are having the one hot encoding, we were having bag of words, one hot encoding, we are having bag of words, we are having TF-ID of vectors, through which we can uh, transform our textual units somehow into the form of one hot encoding, but that is not giving the sufficient information to process the data, right? For example, if we talk about bag of word model, right? So in the bag of word model, what is the process of converting the data, text data, into the form of numerics so that we can apply some deep learning approaches, was that is on the basis of occurrences of each and every word. For suppose that you have given a particular sentence, that is, I saw a dog, right? In this particular sentence, how many times a particular words has been appeared, we are taking into account that count in terms of representing each and every sentence or document into the form of vector, right? So suppose that we have given a document in which 10 sentences are there. So at first we have to came to know that how many number of unique words are there. Then with each and every word, how many times a word has been appeared in a particular sentence, right? So for suppose that in sentence 1, this word has been appeared, so we can take account 1 here, and for rest of the thing we can place the zeros. For rest of the thing we can do. So after all, we are taking into account the number of occurrences here. But what is happening, that this form of transformation of the data should is not reflecting so much information which is resided uh, in a particular uh, textual data, right? So what is happening that every word or every sentence can be, which is having different meaning, can have same kind of vector representation, right? And whenever we were to go to find out the similarity between these vectors, it would be very close to each other. So we may interpret that the two sentences may be having the similar meaning, but it may not be, right? So for suppose that we can say the movie is very good, right? This is one sentence we can take. Another sentence we can take, that is the movie is bad. In both cases, whenever you will convert these two sentences into the form of vectors using backup word models, you will came to know that whatever the vector representation you will form for this, for each and every sentence, they would be looking similar kind, right? And whenever you will apply the similarity function in terms of finding out the similarity, in that case you will get to know that these two sentences are very uh, close to each other, but exactly it is not, right? Actually it is not. So these are some of the drawbacks of uh, these kind of methods here. Please mute the one who has created the noise. Okay. So, what is deep learning here? Deep learning is tend to uh, giving more information into the form of vectors, we can say. So, the main idea to use deep learning approaches is that how we are converting our textual data into the form of vector representation, and that is a very that is playing a major role in terms of processing these kind of data. If you are not representing your data into a very well informed way of vector representation, it would be very hard for you if you are applying any kind of algorithm in that for processing that kind of data. It would be very hard for you to extract the meaning from that, right? So here in the deep learning, representation learning uh, approach has been came into picture, in which you are trying to build the features of a particular text from by learning from the data, whatever the data uh, information is consisting. Through the representation learning, you can be able to learn from that data certain kind of features, and then on that particular features you can apply your deep learning algorithms so that you can get into you can process your data. So deep learning algorithms attempt to learn the representation and the output from raw input text in various levels or in multiple levels. So for suppose that this is your neural network architecture. In this neural network architecture, you have introduced some hidden layers, right? So you can suppose that the first hidden layer is able to capture some basic kind of informations of a particular data. Then the higher level hidden layer can be able to capture the more complex type of features from the data. So it can be able to capture multiple kind of uh, features from simple to complex from the text data. So the reason for exploring the deep learning in the field of NLP is that manually designed features are often overspecified. So whatever the bag of word or TF-IDF uh, TF-IDF features we have discussed. In that case, they are we can say that we are trying to capture some kind of information. And not only this, we can have some custom engineered features. So through that we can also capture the features which has been given in our text. But to engineering this kind of features, it may take it may be over specified, right? We don't know that how these features can be uh, can be performed in this particular sense. And it take a long time to design and validate also. Features are easy to adopt and fast to learn whatever from data you will learn. And deep learning provides a flexible, universal learnable framework for representing uh, word, visual, and linguistic information. Like if we will go through with the word to wake tool, in that case, what is happening that it is a deep learning based approach, or we can say shallow deep learning based approach, in which you are trying to capture the uh, vectorization form of each and every word into a more meaningful form, right? So it may be that you would be able to capture the meaning of a particular word in various direction, right? So this is the feature of deep learning to which we can able to capture in the field of NLP. Deep learning can learn unsupervised and supervised specific labels, right? So, with specific labels like positive or negative. So, deep learning can be applicable in any kind of machine learning uh, approaches. So, this is one thing. And another thing, this is whatever the reason we have given, these are the features or properties of deep learning we can take. And since if we talk about NLP, in the field of NLP, if we will see that deep learning approaches has been came a bit earlier, but they are booming in the field of NLP in quite from earlier decades, right? So why it is not booming so earlier, right? So this is uh, this is because since we have the availability of deep learning techniques, but we don't know that how we have to apply these deep learning approaches in terms of processing the textual data at first. And then once we have came to know, there are so much constraints has been existed at that particular time. So the constraint can be a data, right? Availability of data. So at that particular time, uh, maybe that the availability of data can be a cause for not opting the deep learning techniques, because deep learning techniques are uh, in terms of providing a higher performance using deep learning, you would have the requirement of uh, data, right? High level data, we can say. And then faster machine and multi-core CPU, GPU helps deep learning in the field of NLP also. And new models like transformers or ChatGPT improves much in the field of NLP. So, whenever we are talking about deep learning with NLP, it combines the ideas of deep learning in the domain of NLP in terms of processing the textual data. So, how we are processing the data in terms of representation learning. So, representation learning is to extracting the features from the data, textual data, by learning that particular data, right? Several big improvements in recent years across different NLP labels has been given, and these are the some of the applications we are having. Now, if we compare, so far suppose that we have taken an NLP label, that is morphological level, and if we compare these two techniques, that is what in the traditional approach what we were doing and in the deep learning approach we are doing, you can compare this both, right? So here at the morpheme level or morphological level, we are trying to find out the morpheme, right? So whatever the root word are there for a particular given word, we would like to find out. So we are making some kind of rules here, and on the basis of this, we would like to find out that whether whatever the stem word would be there for a particular given word. So in this example, we have uninterested. So uninterested came has been originated from the stem word that is interest, right? So we have came to know with the rule based approaches. Whereas if we talk about deep learning approaches, every morpheme can be represented as a particular vector, and a neural network combines two vectors into one vector in terms of finding a uh, originated vectors, right? So in this case, you can see here we have every unit has a form of vectors here, and whenever we are combining, it can be represented the origin of the new words here. So in this form, we can represent this. Now, if we talk about the representation of meaning, right? How we are representing the meaning into the deep learning. We will see here. So, a representation, the meaning of a particular word can be represented through a dictionary based approach. So, earlier we can have WordNet or word sense disambiguation like dictionaries, to which we can refer in terms of finding out the meaning, right? Like we can have uh, a resource in which proficient is listed as the synonym of good, right? So here we have given some kind of information that somehow it is this particular word as the meaning of good, which is associated with this particular thing. So this is one thing, but this is also a drawback. It cannot be applicable always for all kind of data, that in every case proficient is not synonym for the good, right? So it can have some more extensive meanings with that. So this is the drawback of if you are using some resources to refer the meaning of a particular word. Another thing which can be drawback, that is whenever so these dictionaries should be updated time to time, because every time new words came into picture, and you would have to uh, be taken into account these words, and you would have to be aware with that particular thing, right? So in that sense, every time you cannot regularly update these kind of resources. So these are the some of the drawbacks. So what we can do, that we can convert our word into the vector form by utilizing some we can say distributional representations, right? So for suppose that a particular word that is uh, Obama, right? Obama is associated with another kind of entities or another kind of places. So how this particular word Obama is associated with, in which instance it is associated with another kind of word, according to that we are giving some kind of meaning, right? And according to that we are generating the vectors into that. So this is the one hot vector representation of a particular word which has been appeared in our corpus. So in this one hot vector encoding, What we are doing, that whatever the unique words we are having, for representing each and every word individually, we are placing one at that particular place of that particular word, and for rest of the places we are putting 0. So if suppose that 10 words are there which are uniquely appeared in your corpus, so the dimension of this particular vector would be 10, and for only one place you would put one to represent this particular word, and for rest of the places you would put zeros. Similarly for the hotel you can do, but this is not representing any kind of meaning, right? Whenever you will process this, it is not representing the meaning. So what you can do, that model has been came into picture for this, that is called, this is that is based on the distribution of semantic, and that is called word to vec, right, which is based on this neural network architecture, in which what you have to do, that how it is generating the meaning, that is purely based on whatever the contextual words are there. So whatever the words has been appeared surrounding to that particular word, on the basis of this it is trying to find out the meaning. So as you can see here, that if there is in our corpus banking word has been appeared, so with the this particular banking word, whatever the surrounding words are there, right, it is taking into account some words which are surrounding with this particular word, and on the basis of this it is trying to find out the vector representation. So here in the word to vec model, they have given two kind of models. That is, one is SIBO model, that is continuous bag of word model, and another is skip gram model. So here we are talking about the skip gram model. So in skip gram model, what is happening, that is, for a given particular word, right, as an input we have given a particular word, and we are trying to predict some of the context word, right? So in this example we have given this particular word banking, and on the basis of this particular word banking we are trying to find out the context word, right? Like we would like to predict this crisis or turning or needs or regulation. This kind of words we are trying to find out, we would like to predict. And in terms of training this particular thing, in terms of predicting from the given input to the contextual word, right, we would train our model, and whatever the weights we have given, we are finding that can be considered as the vector of that particular word. So here
So,
whatever the vectors we
so
are
that is
getting, that can be considered for that particular word a vector representation, right? So here this is having a shallow neural network architecture, in which we have given one hidden layer, and another is the output layer. In the output layer, how many uh, context word we are taking into account, we are considering at a particular time, we have to we have to take that number of units in terms of representing those particular words, and how we are feeding these words into this neural network architecture on the basis of one hot encoding. So previously we have made, for each and every word, we have converted that particular word into one hot encoding vectors, and then from this one hot encoding vectors, every word can be considered as the context word, as well as whatever the current word or center word we are having, and on the basis of this we are trying to predict the this particular thing, right? Here we have, we can see that the current word can be into, and we would like to predict these words that are surrounded with this particular into word. So uh, like this we can have the representation into the form of vector, and you will see that whatever the representation for each and every vector we are finding, that can be uh, considered as the dense vector, right? For each and every place you will get some kind of real values. So real values are tends to a particular feature, we can say, On the basis of this particular feature, we are giving this particular thing, right? So this is about the word to vec model. And you can see the visualization of word to vec, that how they are closely related to each other. So you can see in this particular vector space, uh, expect can be closely connected to the thing, or say, see, want, meet. So these kind of words which are having some relations into the meaning, they have been appeared at a particular same places, we can say, right? They are very close to each other, right? So this is the neural word vector, that how we are converting the textual information into some vector form. And once we have got this vector form, we can apply some deep learning approaches in terms of finding out the solution of a particular problem. For suppose that we are uh, working on sentiment analysis, or we are working on machine translation, in that case we can apply on this particular vector. And not only this, you can train, uh, there can be some pre-trained model, right? On to By utilizing that particular model, you can capture, or you can get the vector representation of a particular word, or you can train your own model on your own data, uh, data is specific to the application, so that you can get more accurate vectors for a particular word. So this is about the word vectors we are having. So now come to the processing part, that how a deep learning models has been introduced, right? So if we so as we have talked about the bag of word or TF-IDF uh, models. So in this TF-IDF or bag of word model base, whenever we are trying to find out any solution, that cannot giving the up-to-date information, or that is not performing, that cannot be performing well, right? So why? Because these kind of models are not maintaining the orders, because whatever the text data we are having, that is a sequential data, we can say, right? So if we are having any kind of sequential data, in that case what we have to do, we have to maintain the order of data, right? So first, in a particular sentence, the starting word can be I, then saw, then then boy. So in this way we have to process the data. For sequential type of data, so this text data can be considered as a sequential data. And for a sequential kind of data, RNN models would work better as compared to another one, right? So how they are building, how they are processing the data, let's see. So I think you all are aware with the deep learning approaches, and how the neural network architectures work, right? So in the neural network architecture, you would have an input layer, then you can have several one or several hidden layer, and then in the last you can have one output layer, right? So the first thing is that how you are feeding your data into the RNNs, right? So in the RNN, suppose that this is your data to which you would like to process, and from this you would like to do some predictions, or you would like to find out that what is the sentiment of this particular word uh, sentence is there. Or you can also apply some machine translation like application, right? So in that case, what would happen, that at each and every time you would process only one word. So for suppose that this is the sequence of words given in a particular sentence. So at first the word would processed, then student word processed, then opened, and then so on, right? So we are processing. the sequentially this particular data sequentially. And why we are processing the data sequentially? Just because we are trying to capturing the order, right? So uh, as a uh, overall we can say that if suppose that this is your uh, and this is your hidden layer, right? And here you have the input, here you have the output. This can be a ANN, right? Artificial neural network architecture. In the RNN, you what you are doing that in terms of maintaining the order, and in terms of taking out the previous words which has been appeared uh, earlier, in terms of producing the next word, or in terms of producing the output, you would have to take into account every time whatever the output you are generating from the hidden layer, that would be considered at the time of input also, right? So that's why you can have a hidden state here, and in terms of producing the output, right? So for suppose that this da word you have processed into the form of vector, right? It can be in any form. It can be word to vec form, or word to vectorization, or it can be one hot encoding vectorization. Any kind of vectorization you can take, but you have to remember that which kind of vectorization you can should take into account, so that you can process the data in more accurate way. So for suppose that this is the word to vec representation of each and every word. Initially, you have taken the hidden state as 0 or nothing, right? Now, every time whenever you are putting the data, you are taking into account the state, previous hidden state uh, information, right? And you are passing this information through a weight matrix here. So once you have given these two information, one is the input and another is the hidden state, with the separate weight matrix here, that is uh, weight matrix for input and weight matrix for the hidden, you will get another hidden state. And then this hidden state would be the input of the another input, right? So this is the input for another stage or another level, we can say. So every time you are feeding a new word here, right? You cannot feed an entire sentence into a particular neural network architecture. Why? Because the sentence can be in various length, right? In varying length, right? You cannot fix the length of a particular sentence. Each and every sentence appeared in the document can have different length. So in that case, what would happen? You cannot decide that how many number of units you would have to take at the input. So in that case, what you have to do, you can fix the size of one particular word in which dimension you can represent one particular word, right? So that's why we would have to take out the RNN as compared to whatever the ANN and another neural network architecture has been existed. But if we talk about the disadvantage of RNN in the field of NLP, that is they are suffering from the exploding gradient or vanishing gradient problem. So so this is the prediction process, that at a particular time how we are doing the predictions, and we are applying the teacher forcing towards the at the time of training of a particular model, right? So for suppose that you have predicted some particular words, right? For so in that particular case, what would happen, that whether this output, whatever you have gained at the end of the output layer, whatever the output you have gained, whether it is correct or incorrect, yeah, at the time of training you will take always the correct output, right? You cannot take the incorrect. If you will take the incorrect output which has been produced from this particular state or level, you can get you can train your model, but it would take more and more time for being conversed, right? So for that particular purpose, you would have to apply the teacher forcing concept in terms of accelerating the training process. So, if we were talking about the disadvantages of RNN, so RNN is suffering from the vanishing gradient and exploding gradient problem. So, what is happening here? That is, whenever you are having such kind of sentences which is having a larger length, right? Or we can have a sentence with, for suppose that 10 words or even 20 words we are having. So in that case, what would happen, that you will get to know that whenever we are applying the back propagation algorithm in terms of updating the weights, these weights, whatever the weights you will update, that would not having the effect of whatever the word you have uh, given to your RNN at the earliest, right? So at first time, whatever the previous words you have given, that can be that can be suffers from the vanishing gradient problem, right? So that in the updation of these kind of weights, you cannot having the effect of that. And for suppose that you would have some filling the blanks type questions in which whatever the predicted word is there, that is totally depend on whatever the first word has been appeared in that particular sentence. So in that case, what would happen, that whenever you will try to predict that particular word, that would be having the effect for the first word which has been appeared. But in this case, since it is suffering from the vanishing gradient problem, it would not get the effect of the first word which has been appeared, right? But suppose that you have the example of IIT Patna, which is running the department in various fields, and it is offering various courses, is situated in. So after in, you have given a blank, right? So you can put here, you can analyze that particular sentence, and you can put the actual answer would be Bihta Patna, right? So uh, this Bheta Patna is the word which can be accurately predicted on the basis of IIT Patna. So IIT Patna is the word which is more effective in terms of predicting that particular word. But if you will apply this RNN, in that case, what would happen, that this particular word should not having the effect at the time of prediction of that particular word. So that's why we cannot we would face the problem of vanishing gradient at the time of RNN. So you can see here that back propagation, at the time of propagation, whenever you are having updation of this particular term, you will apply the chain rule. And in terms of applying the chain rule, whatever the values of each and individual um, unit you will find, that would be something 0.00 uh, in the real value, right? In the decimal form you can get. And once when you will multiply these all values, you will get a very less value which is having uh, not a much effect, right? So in that case, you may not consider this. So then to get rid from this particular situation, we have the LSTM, which we can consider to process our data. But whatever the LSTM we are having, that is based on three kind of gates we are having, that is forget gate, input gate, and whatever the output gate we are having. And on the basis of this, it is trying to maintain two kind of states, right? One state is the hidden state, another is the cell state. So what is happening, that we are suffering from the vanishing gradient problem. So what it tried to do, that it is maintaining short-term memory, as well as it is maintaining separately the long-term memory, right? So long-term memory in the sense that whenever you are listening a particular story, so whatever the parts you have listened earlier, only some part of or some keywords you would have to retain, you can retain in your mind, and on the basis of that you can assume that whatever the story you have listened, right? So in that case, what would happen that for some time else, I talk you, if I ask you that tell me that particular story which I have told you, which I have uh, told you. So in that particular case, what happened that you will pick out that particular keywords which you have retained in your mind, and on the basis of that you will build your own sentences in terms of elaborating that particular story, right? So that's why we are taking into mind our mind that we are considering some kind of keywords, not a whole the story, right? But at the end, whatever the conclusion part is there in the story, that can, for that particular thing, we are having more and more information, but actual information that exactly whatever I have told you, that cannot retain by your mind. So the same thing has been applied here. This LSTM works on the to store the long term memory as well as the short term memory. In terms of storing these things, in this long term memory, it will try to capture the some keywords which has been appeared, which are important and has been appeared in the story earlier. And in the short term memory, it tries to keep the current information which is going on in a particular story. So on the basis of this hypothesis, this LSTM works in the field of NLP, right? And it is having three kinds of gate. One is the forget gate. This is your input gate, and this is your output gate. And on the basis of this, it would try to process the data. But as you can see here, it is having each and every cell is having a much more complex structure. Whereas in the RNN, you are having only one activation function inside that, and you are taking the decision. But here you are having several processing, so much complex structure is there. So at a later time, in approximately 2014, this gated recurrent unit uh, architecture has been came into picture. In that, it is telling that uh, all the at all time you need not to uh, keep the storage of long term memory and short term memory separately. So in that case, this GRU is trying to capture only the uh, hidden state, and it is having some another processing through which it is maintaining the long term as well as short term memory in one state, that is called hidden state or cell state, we can say. And here you will get to know that this is your reset gate and this is your update gate, to which you will take into account in terms of processing the data. So this is are some basics of deep learning to which you can consider. But in NLP domain, what there are various kind of applications are there. They are varying in a very different way. There can be some kind of application which can be mapped from many to one. it ca- there can be some of the application that can be mapped from one to many, and there can be another kind of application that can be mapped to many, right? So if we are having, so for suppose that for this kind of task, we can have sentiment analysis in which we are giving our input in the form of text data, and the output would be as the one keyword which is telling that what is the sentiment of that particular word is there. So that can be a kind of application which is existed into the form of many to one. Another kind of application can be image captioning. So in the case of image captioning, you are giving one image and the caption into the form of human written language can be generated. So that can be comes into the category of one to many. There can be another kind of uh, applications which comes into the category of many to many. That can be machine translation or named entity recognition task or pause tagging task, right? So if we talk about this kind of task, uh, s- uh, that can be uh, have two kind of things. That is, one can be considered as the fixed length or synchronous kind of structure, architecture. Another can be having the sequence to sequence architecture, right? So in this case, this can be applicable for NER or pause tagging, in which you are having as the input many words, and as the output the pause tag of that respective words are there. So for each and every word, exactly one output would be there. So that is in the fixed length, we can say. But in the machine translation, what would happen that each and every word cannot be, there cannot be a fixed length output, that how many words are there in your input, the exactly number of words cannot be at the output, or it is, it cannot be, it would not be in the output. So what is happening that whenever you will observe this machine learning machine translation, in that case, whenever you generate a particular uh, translation of a given word, in that case what would happen that at first you will read that particular sentence, then you will observe, and then you will try to generate the translation of that particular sentence. It would not be that at first I have given you one word of my input and you have generated the translation of that particular word, then second word I have given you, then second word output has been generated, then third word, then third sentence, third output has been generated. So in this case, what is happening that these kind of tasks can be considered as the sequence to sequence task, and in this area there are various kind of architectures has been proposed. One is encoder decoder architecture, right, in which you can consider that whatever the sentence words are there, at first you will push in your network, neural network architecture one by one. That is the part of encoder, you can say, right? And the another part is of the this architecture is the decoder, in which uh, you are trying to generate the predictions of that particular given input. So this is the encoder decoder architecture we are having. But in the encoder decoder architecture, whatever the processing we are having, that is having some kind of drawbacks. So what is the drawback is that at first we are giving all the words to our architecture, and at the end we are trying to generate some hidden state, and on the basis of this hidden state we are trying to do the predictions for our given sentence. But what is happening that the all the load of generation of doing the machine translation has been given on this particular hidden state, that is the call, that's the context vector, right? So in this case, it can also suffer uh, from the problem of vanishing gradient, right? So to get rid from this, we have the introduction of attention mechanism. In this, each and individual word has, after processing each and individual word, we are generating the context word, context vector, and each and every context vector is taken into account to generate or predict the translation of that particular sentence. So what is happening that we are trying to highlighting each and every word which is helpful for each time stem to produce the next word, right? So that is called attention mechanism. In the attention mechanism we are trying to highlighting these parts. Then once we have done this, so once this attention mechanism has came into picture, whatever the task we are accomplishing, they are not really satisfying the performance, right? And in terms of giving these satisfying the performance, there are various kind of attention mechanisms like Bahdanao attention or Luong attention has been came into picture, in which they have given different strategies to give the attention to a particular word at the time of generation the next word. But what is happening that the performance is not improving. So in one of the paper, the authors have suggested that we have whatever the attention mechanism we are using, the cons is not in the attention mechanism, but the cons is that in each and every encoder decoder architecture, whatever the whatever the unit or whatever the cell, which type of cell we are using, that can be cause for this kind of performance. Like in the encoder and decoder, in each encoder and decoder, what are the cell we are having? That is LSTM. You can use GRU or RNN you can use, right? But whatever the cell you are having, they are prone to take the input uh, in a particular in a particular order. At a particular time step, only one word can be processed, right? So if one word can be processed, right? So suppose that you have given so much large data, in that case it would take more and more time in the training process. So at that particular for this particular, to get rid from this particular situation, the attention mechanism has been adopted, but they have this to this LSTM, GRU or RNN architecture. So then they are trying to parallelize this particular mechanism, right? Somehow we can parallelize this particular thing. It would be great to process the data uh, in a very efficient way and time. So for that, we have came to know with the transformer. So in this paper of attention is all you need, you will get to know that transformers has been introduced, and whatever the units has been given, they are all very simple units, and by processing your data through these simple units, you are trying to process your data and you are trying to find out the solution. So here they have used self attention mechanism in terms of processing the data, right? And in terms of ordering to the data, they have used positional encoding. So at a time, parallelly we can process data. And in terms of providing the ordering information, we have given some additional information that is in the form of positional encoding. And then once transformer has been came into picture, it is not possible for everyone in a specific time to train the transformers, because they are having very large data, and they are having so much capacity of system, so that we can train the model of transformer. So every time we cannot do this. So the concept of transfer learning has been came into picture in the field of NLP, since this concept has been adopted very earlier in the field of computer vision and another domain. But in the field of NLP, it has been introduced very later. But why it has been introduced, it is not working well in the in the case of NLP. The thing is that whatever the at the time of transfer learning, so we are having we should have the pre-trained model, right? So at the time of pre-training the model, right? So which kind of on which kind of task we should have to train our model, this is not specified. earlier, right? So you can train your model on the task of machine translation, on the task of named entity recognition, or on the task of any other task, right? But uh, whatever the task has been proposed earlier, and by taking into account this task, they have pre-trained the model. That model is not performing well. Why? Because in this particular task, whatever the task we are talking about, they are not having, they are suffering from a very a huge kind of uh, features, we can say, like we can have, we cannot have so much data which is existed for training your model in the context of machine translation or named entity recognition, because they would like to have such kind of label data in the case of machine translation, so that we can pretend the model. So in this particular paper, universal language fine tuning for text classification, they have proposed a framework in which you can utilize the transfer learning approach with the LSTM in terms of pre-training your model. So in this case, what is happening, that they have, as a pre-trained task, they have taken the language modeling task in terms of uh, doing the pre-training. And why they have taken this language modeling task? Because although it is a very general task, but the availability of data is so much. Whatever the data entirely in the web has been available, that can be taken as the data for uh, training the language model, right? So what we are doing in the language model, that we are trying to predict the next word, next sentence, right? Something kind of this kind of task we can do, right? We can predict one word on the basis of entire sentence. That can be one kind of language modeling task we can have. So on applying this particular task on this LSTM, they have proposed one architecture. And once this paper has been proposed into the field of NLP, along with this particular approach, along with this particular approach, a transformer model has been applied in terms of giving this Google Bert or OpenAI GPT models, right? So these are the pre-trained model, and that has been very successful in the field of NLP in terms of training the uh, application specific models. So you can get more improved performance in a field of, in a domain of a particular application, right? So this is called, whenever these two technologies has been combined, that is transformer and transfer learning, the concept of large language models has been came into picture. And by utilizing these models, uh, you will go through with the you have now observe the chat GPT, right? So chat GPT is an application which is based on OpenAI GPT model, right? So there are various versions available for GPT, that is 2, 3, 4. They have released, which is released by OpenAI. So and you have seen that what is the performance of chat GPT is here. So this is a an overview of whatever you are having in the field of NLP, and how the NLP field has been revolutionized after the introduction of transformer model, which is based on deep learning approach, right? So this is whatever the language modeling task to which we have discussed earlier, that whatever suppose that you would like to predict a particular word for a given set of word, the next word should be predicted on the basis of whatever the words you have given, right? So how you can do this? So if you will see that uh, this particular problem can be simulated or can be modeled in a way that is, for suppose that you have given particular data, right? You have given this data. In this data, each and every sentence can be utilized to create a dummy data, right? So dummy data in the sense that you are trying to predict next word from a given set of text word, right? So for suppose that I am taking a sentence that is, hi, my name is Pradeepika. So, in terms of this is the sentence which is in your training data. So, in terms of creating the dummy data, at a particular time, you can take this first word. On the basis of this word, what word should be predicted? That is my. The next data can be taken as hi, my. On the basis of these two words, which word should be predicted? The next word can be predicted as name. Hi, my uh, name. What words should be predicted in the next? That is, and so on. So in this way, we can create a dummy data in which we are at the right hand side, we are having the input, and at the left hand side, we have the output. And by doing so, we can apply deep learning approaches in that. You can apply LSTM, RNN, or transformer in terms of building this word predictor, right? So at first, for if this kind of input you are having, for this kind of input, what you can do, you can convert at first this data into the form of some vectors. You can use one hot encoding or any kind of word vectors, right? And then you will apply that word vectorization into the neural network architecture, in which each cell can be RNN, LSTM, GRU, or you can do the parallelization of this particular processing using the transformer model in terms of predicting these words. And through training this particular process, you will get to uh, have the weights, and on the basis of that, you can came to know the prediction. So here I have given some of the uh, Google Colab implementation using LSTM. You can go yourself in the slide, and you will see that how the word has been predicted, right? At the end, at the testing time, if you will see that I have given this kind of sequence, and I would try to find the next word up to the length of this word. The sentence is 10 or more, right? So range is 10 or more we have given. So up to this length, the word has been predicted in this way. So this is the word prediction task to which we have discussed. If you have any query, you may ask.
Dear attendees, you can unmute yourself for asking any query. I think there is no query, ma'am.
Okay.
Uh, Thank you so much, ma'am, for your wonderful session and sharing valuable knowledge. Now it's time to thanks to ma'am. Nilima, ma'am, now it's over to you.
Okay, thanks, Abhishant. Good evening to everyone present. It is with great gratitude that I take this opportunity to extend my heartfelt thanks to Dr. Pradeepika Verma, for delivering an insightful and thoughtful provoking session on deep learning in natural language processing as a part of this Atal FTP. Your deep expertise, engaging presentation, and invaluable insights have provided us with a comprehensive understanding of how deep learning is revolutionizing NLP, shaping the future of AI driven communication and enhancing language processing capabilities. The knowledge you have shared today will undoubtedly inspire and guide our academic and research pursuits in the ever evolving domain. On behalf of Atal FDP Organizing Committee and all the participants, we sincerely appreciate your time, effort, and dedication in making this session both enriching and enlightening. We look forward to continue learning from your expertise and hope to have more opportunities to collaborate in the future. Once again, thank you for your invaluable contribution, and we hope to stay connected for more such intellectual stimulating engagement. Thank you, ma'am. Thank you so much for your time and efforts. Thank you.
Thank you. Thank you so much, sir. And thank you so
Thank
much,
you,
ma'am.
ma'am. Thank you.
Yeah.
Thank you, ma'am. Thank you, ma'am.
Thank
Thank you.
you.
Thank you, ma'am. Thank you.
Okay.
Yeah. Look
Okay, sir.
forward to have more sessions of your ma'am. Thank you.
Yes, definitely, sir.
Thank you.